Hello สวัสดีครับท่านผู้ชมผู้ฟังทั้งหลาย Today is first day that first time that we do a webinar series. We starting this webinar, I think something that we have not done before, and I think today we're gonna talk a lot about something in the past, and then we have a special guest today, and also the special addition to the NIPA Cloud team. Randy Bias on my right hand side here, and before that, let me talk a little bit about NIPA Cloud. Okay, NIPA Cloud is Thailand public cloud provider, and we provide public cloud, private cloud, hybrid cloud, and multi-cloud environment to all the users, especially here in Thailand. But we plan to go around East Asia and all this region. So we have using the open source software like OpenStack, Ceph Storage, and Tungsten Fabric to make this of the new environment of the public cloud user here.
Yeah.
I'll let you introduce yourself a little bit, okay? How you come up here and what is your background? I know you're really, I mean, if you look at his profile before, it's really amazing that we have Randy sitting here on his side. He's really a cloud pioneer for original cloud computing of the world as well. And he originated from Silicon Valley, and let him introduce himself a little bit. Okay, Randy, go ahead.
All right. Thanks for talking me up. My name is Randy Bias. I spent 30 years in the Silicon Valley working in tech, starting with systems engineering, then network engineering, then cybersecurity, then building data centers. That was actually the first time I came out here. I worked in Hong Kong in 2000, 2001, building some large-scale data centers in Hong Kong, Taipei, and Seoul, and then went back to the United States and did a bunch of stuff in early cloud, SaaS, things like that. And then was part of really kind of the early cloud computing movement as a blogger and as an innovator. Right? My first startup that was one that I founded, as opposed to one that I worked at, was building sort of DevOps tooling before there was such a word as DevOps. And I was using this system called Amazon Web Services Elastic Compute Cloud. It was in private beta. That was December of 2006 when we were building this technology.
No, that's why we call him cloud computing pioneer.
Yeah, very early on.
Way back in 2006.
I'm always bad. I'm always too early. So like I was doing cybersecurity in 97, 98, 99. That was very early on. I was doing backbone engineering in 93, 94, building out ISPs. I mean,
and you have your own company at the time for providing a cloud, right? Private cloud, like cloud scaling.
Yeah, so cloud scaling was my second attempt at a startup, and that was founded in 2010. And we were using OpenStack. We were one of the first products based off of OpenStack. Some really great wins. We built the first public cloud in Korea for Korea Telecom. We built the first telco cloud for AT&T in the United States. Built the first large-scale private retail cloud for Walmart, which, Walmart is
and they're still using it today, right?
Still using it today, to the best of my knowledge.
Yeah. Walmart has used a lot of OpenStack cloud.
Yeah.
As far as I know, and okay. After that, then I think you're working as the original founder of OpenStack as well, right?
Right. So cloud scaling, my startup, the second startup that was successful, we were part of the original launch of OpenStack in summer 2010. And then when the OpenStack community decided to form Foundation, Cloud Scaling and myself were one of the original founding members of the OpenStack Foundation, and I sat on the board of directors for 3-4 years.
And just to remind people here a little bit, OpenStack, this is the 12-year OpenStack celebration, right? 10, 11,
13?
13 years celebration.
Be 13. Be 13 this year.
That's about time that when Randy started up, and now we have OpenStack and NIPA Cloud using fully OpenStack version, and it's been amazing using OpenStack. And then after that, Randy also found the tungsten fabric, which is another open source networking or SDN project, right?
Yeah, so Tungsten Fabric is a open source software-defined networking platform that came out of a commercial project that Juniper Networks acquired called Contrail. In 2017, I led the charge while I was at Juniper in open sourcing Tungsten Fabric, or re-open sourcing it, I guess you could say, and putting it into the Linux Foundation, where I also sat on the board of directors and helped with oversight.
Yeah. Just give you background a little bit. At NIPA Cloud, we use Tungsten Fabric because we want to scale. And currently, let me get back a little bit. Before Tungsten Fabric, we use OpenStack, and I think we use OpenSwitch, and it prevents us from scaling.
So Open vSwitch didn't scale.
And didn't scale and all this stuff. So we decide and we do a lot of research on Tungsten Fabric at the time. And this is about 4 years ago. And then I think we found that it's very good open source program for the SDN. So we switched this one, and now we can expand, we can scale. We have Bangkok, Nonthaburi location, and then Khon Kaen location, and we start to expanding around Thailand as well. So it makes us easier to scale in this part. So thanks to you for setting up that Tungsten Fabric.
I wasn't the one who wrote the code. I was just the one who helped open source it and market it and make it successful as an open source project.
Okay, great. Just to remind audience a little bit, we're just going to chat a little bit until we get some good number, maybe another 10, 15 minutes, and then we're going to start right into the talk, which Randy is going to talk about. The topic, as you see on the screen, is adapt or die, and disruption in this in the IT era. I think Randy will give you a great perspective of what's going on in the past and what you should expect in the future as well.
And we'll do some Q&A afterwards, so stick around and prepare your questions.
Right. And we're going to talk a little bit more on the other subject, like we heard a lot of VMware acquired by Broadcom.
Yeah, the Broadcom acquisition is finalized now, I believe.
Finalized, yeah. So what, 62 billion or 61 billion?
I've seen 61 and 69 billion, actually. Yes, I've seen both those numbers. But largest IT transaction ever. Largest acquisition. Yeah. The funny thing is I was EMC had acquired my company Cloud Scaling previously, and then they were acquired by Dell, which at that time was the largest IT transaction, and VMware was still part of EMC at that time, and I think that was like 51 billion. And so now VMware is being valued all by itself at 60 billion plus, which is pretty crazy.
Yeah, really crazy. But I think you can see the trend. Broadcom is almost like a chip maker, right? A hardware company. Now they acquired a software company, which is VMware.
Well, they've got some history of making acquisitions and kind of trying to streamline those acquisitions and squeeze as much cash flow out of them as possible, and we can already see that starting to happen with them getting rid of perpetual licenses and forcing all new sales onto a subscription license basis, which doesn't work out as well financially for a lot of folks over a longer term, 3 to 5 years.
Right. So definitely it's going to be kind of really expensive to use the VMware as a private cloud, mostly private cloud. I think they're going to expand into something like with the public cloud, and they join hand with AWS. But anyway, those are the big part of the VMware, and I think that we should understand the nature of it a little bit because a lot of people here in this region, they first migration to cloud, and I think a lot of them also use VMware. But with this part of acquisition, I think it will be it may change the landscape. I don't know how big it is, but the first announcement is that they're gonna cancel the perpetual thing, and it's gonna be all subscription.
I mean, I think it's going to be a big change. You can already see sort of a sea change now with a lot of people looking to get off of VMware, and I think it's a good thing for cloud in general because a lot of folks are still confused about what cloud is, especially here in Asia. It seems like a little bit behind. It was 11, 12 years ago we were arguing about is cloud virtualization, is it on demand, is it APIs, and we sorted through all of that stuff, very quickly. And I remember one panel I was running where it was a bunch of guys who had been chief architects for bare metal clouds. And I had a whole bunch of the other cloud pundits at the time get really sort of, upset and saying, oh no, it's got to be virtualization. And they were heckling my panelists, and I got up to the front of the stage and I said, let me ask the crowd something. If I can give you bare metal on demand, and it's through an API, and the server comes up in 5 minutes, and it's whatever operating system you want, is that still cloud for you? Raise your hand. And everybody raised their hands. Because it doesn't really matter if it's a container, a VM, or a piece of bare metal. What matters is you get that sort of frictionless experience, you pay for it as you use it, and you're able to scale it up and down easily.
Okay, that's great. So that's part of things have changed in the past, but I think in this region, as you may know, that we kind of are slow and kind of behind on the part of whatever you've been through on the West Coast, and that's at that time. So I think we can learn a lot from Randy today. I think it's we can talk one last thing about the another interesting topic that I see is about the local cloud benefit. I'd like to touch upon here a little bit here. It's the recently we heard a lot of sovereign cloud, right? Sovereign clouds mean that the cloud that will provide you all the thing that you can own, and you have the right to do whatever you want. I think this is something that's important, especially for NIPA Cloud, that we can provide the sovereign cloud to all the people here in Thailand, especially when you want to look at the data sovereignty. I think it's the key to maintain your data here in Thailand as much as you can. Recently, we heard of AWS talk about sovereign cloud. Can you elaborate or give us some more on that?
Yes.
What it is and then what happened?
So recently, Amazon opened up a European sovereign cloud, and the idea is to provide data sovereignty and guarantees around privacy for the citizens of those countries. And if you stop and you think about it, the United States government and a lot of United States businesses operating in the United States are not going to put their infrastructure and applications on top of, say, a Russian-owned and operated cloud in the United States, or a Chinese-owned and operated cloud in the United States. And Europe has felt that way from the very beginning. And so Amazon Web Services, of course, is responding and trying to make some guarantees around a whole new region called the Sovereign Cloud, so that they can provide data sovereignty guarantees, so they can guarantee it's only European Union citizens that are running and operating that cloud and so on. And so I think we're going to start to see this more and more over time, where countries realize that for critical national assets, whether it's power, hydroelectric dams, logistics, whatever it is that people are dependent on, that they're going to want to basically be able to do that on their own systems that are owned and operated by citizens of that country. So you'll see more and more of this shift towards sort of thinking about sovereign clouds in the future, local clouds.
Yeah, because once you move over to cloud more, you have to start thinking about all the data that you own, where it's keeping, where it's kept. That's the key. Yeah. But the cloud itself kind of blur the whole thing.
Yeah, it makes it all this kind of like bubble, and you think it's just in the cloud, but it's actually sitting on somebody's server somewhere.
Exactly, and it's almost like a black box. You can call that one. Okay, I think maybe it's time for us to cut right into the Randy talk today, adapt or die, and disruption in IT eras. Now, we're going to switch to tape recording of what Randy is going to talk about, because we want to make sure that the local Thai people can understand that. So when Randy talk, we need to put some subscription or closed caption on the bottom in Thai for all of them. So we decided to pre-record the talk, but Randy and I will come back after the talk to answer all of your questions as well. Okay, Randy, are you
great? Let's go.
Ready? Okay, let's go.
Hi,
I'm Randy Bias. Thanks for coming today for our webinar, Adapt or Die, Disruption in IT Eras. I'm really excited to be presenting for you all. This is my first time doing a presentation in Thailand. I've presented all over Asia, but never in Thailand before. So we're trying something new where we're recording this in advance so that we can do closed caption in Thai. All right, so who am I? Why should you listen to me? I think it's really simple. 30 years in the Silicon Valley, building infrastructure, one of the earliest people in cloud computing, longtime cloud pundit. My startup Cloud Scaling was one of the earliest OpenStack product companies. I was part of the whole OpenStack movement. I was part of the DevOps movement before it was called DevOps. I was part of that group of bloggers and pundits who helped to coin the term cloud native. Amongst the many things I've done, I built the first public cloud in South Korea for Korea Telecom. I built the first telco cloud for AT&T. That was 2011, 2012. And of course, a very large-scale private cloud for Walmart. So I learned a lot of things over the last 30 years, and I'm happy to share that with you today. So it's important to remember that at one point in time, businesses had no access to computers of any kind, right? We didn't have these mobile phones. We didn't have desktops or laptops. In fact, businesses operated without computers. It was about the 1960s that IBM, along with American Airlines, took one of the first mainframes and built one of the first mainframe applications on top of it called Sabre, the first electronic airline reservation system. So that's really the first time that we saw disruption in with advent of a new computing era, right? Just the ability to use computers to basically get some kind of structural competitive advantage against your competitors. So American Airlines in the 1960s going into the 1970s was dominant in the airline industry in the United States of America because they had an electronic reservation system and nobody else did. So that was really the beginning of computing for business. Then as we moved into the 1980s, the 1990s, we had the next major shift, right? We had more players. It wasn't just the mainframe guys. We had what I call the enterprise computing players. We had the shift more to the client-server model. So some of our server capacity was in the data centers. Some of our compute capacity, I should say, was on our desktops and our laptops. And we started to see this other shift as well, which is that almost any business that had some kind of buying power could start to use information technology to get some kind of competitive advantage. And at the same time, they were using technology to do things that didn't provide competitive advantage. And we're going to talk about that a little bit in a moment. So this really brings us to the third major era in computing, which is the cloud computing era. And this is, again, another tectonic shift that disrupted kind of the models that came before. Now we've moved to a model where you can go and you can get servers on demand from somebody like Amazon Web Services. It's just like if you were going to get utility power, right? So I like to sort of ask people, if you went to your developers and you asked, what can you do if you can have 10,000 servers for an hour for only 10,000 baht? What does that mean? Well, can you do something new? And the answer is yes. The reality is that as we've moved towards that cloud computing era, we've shifted in sort of major architectural disruptions. We're going to talk about that in a little bit. So let's talk about these changes from the mainframe computing era to the enterprise computing era to the cloud computing era. So in the mainframe era, we had applications that were designed to run on these, high uptime machines, these big iron machines like mainframes. A lot of the time that the hardware was customized on an application by application approach. Everything was centralized. You had one application or a few applications running on top of a big metal box. All the high availability was in hardware, not software. There's very little automation, pretty much no APIs. And then as we started to shift into that enterprise era, we see sort of more of this distributed and more decentralized kind of model. We're moving to a mix of high availability through hardware and software. We see more of a shared service again. You've got some people running servers in the data center, your operations and IT folks, and then there are people running their own laptops, right? So you've got this distribution. So this centralized model where everything's in one place and people have to go and ask for permission to get time on the mainframe. Instead, now you've got servers in the data center that have different purposes, file servers, mail servers, ERP, CRM, whatever it is, and then you've got people doing their day-to-day work on their laptops or desktops. Then as we move into cloud, it starts to even shift more dramatically from an architectural point of view, right? I mean, when's the last time that you saw Gmail down? It's never down. It's always on. What happens is that some parts of Gmail, some users for Gmail can't log in or have a problem, but you never see all of Gmail down. And that's because those hyperscalers have really designed for a completely different model. It's 100% high availability in software, the ability to route around failures. So that allows them to operate on commodity hardware, and it's much more of a distributed self-service model, right? You can go to the APIs, order as many servers as you want, pay by the drink, which means you order 100 servers for 10 hours, you pay for 100 servers for 10 hours, you shut them off, you pay no longer, right? It's a very different, much more fluid type of architecture and just way that we approach information technology. So let's talk about today's disruption, which is really that shift from enterprise to cloud. Let's dig into it a little bit deeper. So I'm sure you're all familiar with how enterprise computing works, right? You need a server in the data center, you go fill out a ticket, right? You have to talk to your IT guy, you have to get permission. You know, you sort of have this very weird model that looks very similar to how Henry Ford built sort of the first assembly line for cars, right? You've got these specialists, you've got the storage guy, you got the network guy, you've got the security guy. And so what happens if you want to put an application in the data centers, you have this assembly car model where you've got each one has to do their tests. So you fill out a ticket and then they start the process of building up some infrastructure so that you can put your application in your data center, right? So server guy gets the servers ready, network guy gets the network ready, security guy validates your security, and you go through this process. So you need 10 servers in the data center, no problem, wait 6 months, and then you can put your application on top of it. And that's really sort of the old way of doing things. In the new way, you really need to think of the data center more like a robotics factory, right? Or, you know, really the cloud more than the data center, right? Everything's fully automated. You don't have these specialists on the line. You move from specialists on the line to people like the Google SRE model, where you've got people who are cross-cutting multidisciplinarians, really the people who program the robots. Call it DevOps, call it SRE, whatever you want. But we move from this model of having handcrafted infrastructure and applications to the people who know how to program the robots to basically allow you to develop and deploy and manage your application at scale very rapidly. So this is a really important point, right? If we look at the enterprise, the classic enterprise application model, right? A lot of those enterprise applications are designed for, 2-3 nines of uptime. And then what happens is, in order to de-risk the chance of the application going down, we sort of gold plate the hardware. We try to make the hardware 4 or 5 nines, right? Make everything HA, 2 HA switches, 2 HA routers, 2 HA load balancers, 2 all the way down. And then what happens is that the application's still only 2 or 3 nines, right? Because it doesn't really matter how highly available the hardware is compared to the software, which is really that model that cloud represents. Cloud applications are designed to route around failures, right? Again, look at Gmail, look at anything that's cloud native, that's run in a Kubernetes cluster, for example. And those applications are really designed for 4 or 5 nines because they detect problems in the lower parts of the stack, and they act on those problems and route around those failures. So now you can build a 4 or 5 nine application, and you don't care how highly available that the hardware is. You can run it on 2 or 3 nine hardware, which means you can buy cheaper, less expensive hardware and design more for that scale out model. So over the years, I've really had to try to figure out how to explain this concept of kind of the old way versus the new way as concisely as possible. And I eventually hit upon sort of the notion of thinking about your servers in 2 different ways. In the first way, you think about your servers as being pets, right? Every server is special. It's got a name. If it gets sick,
You need to nurse it back to health. Everybody is there, all hands on deck, right? The mail server goes down. The CEO can't get his email. Oh my gosh, everybody do everything to fix the mail server so the CEO can get his email, right? In the new way, you really think about servers as being disposable, right? Again, they're cheaper, commodity boxes. It's like web servers, www1 to www99, right? If any of those servers get sick, you just basically take it out back and shoot it in the head, right? And then that you replace it on the line. And so that sort of notion of kind of pets versus cattle in terms of how you think about your servers is critical to understanding the difference between the enterprise way and the cloud way. If you are so worried about your servers being sick or having problems that you are focused on the server instead of the application that runs on top of it, you're doing it wrong. So the person who kind of outlined this best is Satya Nadella, the CEO of Microsoft. He pointed out that if you have a new generation of applications, that they require a new kind of infrastructure, which we just talked about. And it's critical that we really internalize this, right? If we keep doing things the old way, we're going to get the old results. We need to start doing things the new way. So looking at how those apps are and across these different eras, right? Again, bringing it home, right? We have mainframes that have one or a few apps on them, and that's all they run. So for example, even still today, Visa does all of your credit card transactions over 4 mainframes globally. They just keep making the mainframes bigger and bigger and bigger and scaling them up as there's more and more demand. But it's just a few applications that run on top of that mainframe. And it's all in one big silo, right? There's no virtualization, or at least virtualization as we know. There's mainframe virtualization, that's a different story. Let's not get into that. And then when we look at sort of enterprise applications, again, we attempted to basically try to make the hardware as highly available as possible. That whole notion of having high availability pairs. You look at anywhere in the data center today, again, you're going to see 2 of everything, 2 firewalls, 2 load balancers, 2 databases. It's just 2, 2, 2, 2, 2. And we get some leverage out of that, but the reality is that it's not the architecture going forward, which is really that cloud native approach. With the cloud native approach, the applications themselves are smart, right? They know how to deploy themselves, they know how to manage themselves, they know how to query the APIs of the underlying infrastructure that they run. They can scale themselves up or down dynamically. They're run in a scale out model, so instead of just having 2 of everything, you've got N. Instead of 2 databases, if you're using Cassandra or another NoSQL data store, you can run 10, 100, 50,000 data stores, right? So it's just a really different way of thinking about how we handle the architectures. So you're going to probably say to yourself, okay, what do I do with this, right? I've got this big application portfolio now, running my business on a bunch of different things. And it's pretty simple, right? We've got applications that were really built, sort of to run on mainframes, that legacy era, and those just stay there. And then we've got applications that were born in the cloud era, right? And they're just already built native for the cloud. You don't need to worry about them. It's really that thick middle of applications that we've been using since the 90s, 2000s that might be still sticking around in our data centers that are problematic. And for each of those, you can kind of triage and you could say, does this belong still on this more expensive classic enterprise virtualization system, or should it be moved to cloud? And what's funny is that a lot of those applications are already almost cloud native, right? If we look at pretty much any web application that was built since the late 1990s, the web layer is N web servers with load balancers on top of it, right? Really, the layer of the application that's problematic is your data store. So you've got 2 relational databases paired up, active-active or active-passive. And if you can convert those to a NoSQL data store, you've just turned your app into a cloud native or mostly cloud native application. So Nick Carr in the mid 2000s wrote this rather infamous book called Does IT Matter? And Nick had this notion that just like highways and the power grid and railway and telecommunications, that as we matured in terms of how we built and managed and orchestrated information technology, that businesses would basically consolidate those capabilities and start to offer them as a utility-like service. So this predates early cloud, but it signals that the cloud was coming, right? And a big part of this is that if you think about it, anything that you're doing to spend on IT that doesn't provide you competitive advantage is money that's wasted, right? If you're running your own email server, that's wasted money, right? That technology provides you no competitive advantage of any kind, right? And almost nobody does that anymore. We all know this, right? I'm pretty sure almost everybody is using outsourced email now, whether it's Outlook or whether it's Google Mail. And the reality is we have to look at that whole app portfolio sort of through that lens, right? Or we have to look at what we're spending on infrastructure, right? Is the money that we're spending helping our business have a competitive advantage against our competitors, or are we spending it on generic IT services that don't do anything, right? Or at least nothing to help our business. So this is one of my favorite quotes. It's from a Forrester analyst, Craig LeClaire. He basically pointed out that just 10 years ago, at the time of the quote, 70% of the companies that were on the Fortune 1000 list were no longer there. 70%. I mean, 700 companies disappeared from the Fortune 1000 list over the course of 10 years. How does that happen? That happens because businesses don't adapt. They don't adapt, so they die, or they're displaced by others, right? So let's talk about a great example. Netflix is an amazing example of embracing disruption and embracing change. I'm sure you're all familiar with Netflix. If you don't have it, then I'm sure that you've seen it or that you've played with it. But maybe you don't know the story. So Netflix started off shipping physical DVDs, movies, to people's homes for a monthly subscription. No video streaming. And it was really after about 4 or 5 years, as you can see from the timeline here, that they realized that they needed to do video streaming and that was a way that they were going to get to the future and disrupt the existing guys like Blockbuster in the United States who allowed rental DVDs. So they started to figure out how they would do that. And they saw some immediate problems. One of the immediate problems was that they had that classic enterprise computing model. They were running IBM servers, Oracle databases, everything was 222 in the data center. So they weren't really designed to get in a position where they could scale radically. About the same time, Amazon Web Services EC2 basically came about. It was in private beta in 2006 when I first used it. And then in 2007 to 2008 is when it went public. And Netflix announced that they were going to start migrating from their existing data center to cloud. But more importantly, they announced that they were going to re-architect their entire application architecture for video streaming into something that was cloud native and was designed to scale to massive scale over time. A big endeavor, but something that clearly shows that they saw the future. More importantly, as you can see by the timeline here, is that they were able to figure out how to ride Amazon Web Services growth rate, or international expansion, I should say. So you think about it, Netflix is only in the United States. They just started doing video streaming. They're getting going. They start doing video streaming to Canada from the United States. Then Amazon opens up in Europe. Now, Netflix, who's put all this work into fully automating how they deploy and manage and have architected their video streaming service, is able to simply turn and point all of their automation to the European region, the new Amazon Web Services European region, push a button, and then a few hours or days later, Amazon's up and running in Europe. Nobody had to get on a plane. Nobody had to sign a data center contract. Nobody had to negotiate network and peering agreements. No boots were ever on the ground. Instead, now Netflix is in an entirely new region, has entirely new customer bases, and all they had to do was press a button. And then they're able to replicate that again in South America, in Asia, and all over the world. And we know what that means today. What that means today is that they've gone, on a rocket ship in terms of growth and stock valuation. Right here, you can just see the time frame from 2008 to 2016 when Netflix completes its move from their own on-prem data center to Amazon Web Services, going 100% cloud native, embracing cloud computing principles, and that allowed them to go on that rocket ship ride. This is a posting from the Netflix blog that sort of talked about wrapping this all up. And it really brings home those points that I've been harping on through this whole presentation, which is that cloud really allowed them to take, to build reliable software that ran on top of unreliable hardware. Again, that 5 nines at the software layer running on top of 2.9 or 3.5 9 infrastructure. And then second was that, they weren't really trying to reduce costs. Right? Only losers are trying to reduce costs. Winners are trying to move and grow faster than their competitors. But they found out that they wound up reducing costs because as they've automated the way that their video streaming service works, it scales up when they have more demand and then it scales down when they have less demand. And so on average, they're able to actually reduce their costs. And then again, it was that thing of really re-architecting from that classic monolithic enterprise style architecture into that new cloud native cloud computing architecture that allowed them to do this. All right, so I've talked about kind of today's disruption. Let's talk about tomorrow's disruption because I think that's where the fun part is. So I think really there's this fourth era of computing, IT computing coming. And I call it autonomous computing. And it's early. We're speculating a little bit, right? So let me give myself a little rope to hang myself. But let's walk through what it might look like. What is autonomous computing? We already know about autonomous driving, and people probably know that most commercial airlines have been using autopilot for 20 or 30 years for the airline industry. But we're seeing this general shift as artificial intelligence becomes part of the mainstream, and I think it's going to become more and more ingrained into the way that we do IT. So autonomous computing is this notion that's built on top of cloud computing. Since we have things that are more fully automated, we've got many APIs, we've got high levels of automation. What happens if we have artificial intelligence assistance for operations? We can move to a very different model, right? So we've got automated scaling up and down, but if we have an artificial intelligence that's sitting there and helping us run our applications in real time, we can potentially do some new things. We can predict failures before they happen and take action. We can figure out how to predictively scale. We can scale before we need to scale, right? We can have autonomic operations. So we can figure out ways where if there's an issue in production that's happening when there's key triggers, that we can sort of set up an autonomic response that an AI can trigger all by itself or, with the assistance of a human. We could get away from that notion of scaling vertically up versus scaling horizontally out. Right now, it's a little bit of an either-or proposition, but you could take sort of those classic enterprise applications and lift and shift them with their relational databases onto cloud, and AI could see that you were going to run out of oomph on your database servers, whether it's IOPS or RAM or CPU, and it could spin up new servers that were larger and then automate the process of migrating all of your data in real time to those servers, right? So now we can scale up and out. This notion of self-service that's key to cloud computing, right? It's all through APIs or maybe a GUI. But you can imagine that you want to interact with your application and you can do it through voice or you could do it through text, just like we do with ChatGPT today. You can have sort of this way of actually interfacing with the AI that's more of kind of the natural language interface. And then, of course, that's all going to require more extreme automation and ubiquitous APIs everywhere. So this is just a graph I threw in here to kind of show you where AI is going. I think almost everybody knows this. Maybe this is even underselling it, but Statista is showing or predicting that we're going to see 10x growth in artificial intelligence over the next many years. And then this is a State of AI report coming out of DataStax, one of the leaders in artificial intelligence solutions. And it really is just telling us two things. One, that business leaders understand that AI is going to make a big difference to their business, and so they're going to embrace it, hopefully. And then second, a key here is that it's not really about the computers doing the work. It's about human assistance, right? So it's humans assisted by AI being augmented and being able to be 2, 3, 10 times more effective than they have in the past. And they're competing against unaugmented or unassisted human beings without AI. So what might look like? Again, we can definitely say that autonomous computing is something that rides on top of the cloud computing era, right? It requires APIs. It requires things like Kubernetes, dynamic scaling, public and private cloud, infrastructure as code, DevOps, all of those things that we're using today in cloud. But they're really going to be driven a lot more by AI or humans assisted by AI. So if we look at developers, what might that mean? Automated coverage tests. Right now, a lot of the time you look at internally developed applications and they maybe have 50, 60, 70% test coverage. You could have 90 or 100% test coverage as the AI is assisting in building those tests. Software development lifecycle workflow automation, right? Being able to actually smooth the process so that AI is assisting in each of the steps as you go through software development, helping you get from end to end, from the code to production in a faster way, releasing code in a much faster way, automating code comments, right? Right now, people or developers can be lazy about commenting code. The AI can just do it for them. Probably more interesting is on the ops side, right? Like when we were talking about sort of these autonomic operations, but it's really interesting, right? You could have an AI that assists an operator do root cause analysis. Some kind of failure happens in production. Normally an operator's got to go and look through all the logs and try to figure out where the errors are and do correlation. The AI with access to all that data could do it in minutes or even seconds and provide that to the operator to basically make a judgment call on what the actual root cause was. Infrastructure as code generator. Right now, everything we do around DevOps or infrastructure as a code where we automate the deployment of applications is humans, manually writing all of that code. The AI can be writing that code for us. And then, lastly, I've been thinking a lot about this notion of continuous management, which we talked about a couple slides ago, but it's really that notion that we're going to go beyond sort of automating the deployments of applications and automating the scaling to automating the entire life cycle where the AI is helping us continuously monitor it. It's looking for, future problems. It's looking at historical data. It's looking at potentially even real-time news information that might tell them when there's going to be a spike in traffic and actually very proactively managing the application rather than reactively managing the application. So that was a lot for today, and some of it was speculative there at the end, but really just to wrap this up, good businesses that want to be competitive and want to defeat their competitors are ones that are going to adapt to and embrace new technologies, right? They're going to use these technologies in a way that allows them to get competitive advantage, and they're not going to hide their heads in the sand. So it's really up to you to disrupt or be disrupted and to embrace the new. Thank you for joining our webinar today, and I'll take any questions you have.
Okay, we're back. Great presentation, Randy. I
Thank
think you gave really a good overview of what's happened in the past, up until now, and then what's future going to be. I think a lot of people here, especially in Thailand, didn't understand it. What is a computing era is. I think now they do. Hopefully that they can adapt to it. I think a lot of people here listen to this presentation here. They're probably in the cloud computing era and DevOps era, cloud native eras, but they don't understand what's happened in the past. I think today they will understand it much better. And I think in the future, I think we would understand that really clearly that it's going to be like a quantum computing and AI and ML. So that things will come. I think we all have to be aware of what happened in the past. So
yeah, well, that key takeaway from the presentation is that if you see these transitions starting to happen and you kind of lean back and you don't lean into it, you're not embracing and trying to use the change to facilitate your business and give it a competitive advantage, somebody else is going to do that, right? So Dropbox, many people use Dropbox. It all started off on AWS. Companies like Airbnb and Uber started there. The ability to use cloud computing and the changes, the example I gave in the webinar with Netflix, that allows businesses to actually get ahead of their competitors. So if you can't embrace new technology as a business culturally, then you're gonna fail at that adapt or die proposition.
Yeah, but your Netflix example is very good example of one company that's starting with something like really old-fashioned way, send with CD. Now they become the huge company around the world. And,
Yeah, poster child for cloud native.
that's right. Yeah. Okay. So amazing on that one. There's a question coming from audience. Okay. All right. The first one is what is the driving force behind the shift from on-premise hardware infrastructure to cloud-based solution, and how this affected the scalability and flexibility of IT environments? It's a long question.
Yeah, so this is a tricky one because I think there's actually several different driving forces. So the first is that in the enterprise computing era that I talk about in the webinar, people really started spending money on things that didn't make sense, like running their own mail servers, running their own DNS servers, all those things that didn't have anything to do with their core business. And they were bad at it. I remember going to Kaiser Permanente, which is a medical company, healthcare company on the West Coast, and they would charge, their internal IT department would cross-charge another department $10,000 for a $2,500 server of 4x markup. And somebody like Amazon and Google, Facebook, all the hyperscalers, they can deliver these services at very low cost. And at the same time, you've got these traditional enterprises who are just highly dysfunctional. So that's one, was cost. Number two is the ability to scale quickly, right? So a lot of the startups really got on Amazon because they wanted to have that viral moment when something went crazy, and then they're able to scale up their systems as quick as they have new users. And that's something that just couldn't be done before. So those are two really big drivers for the change.
Great. Okay. Thanks for the question. I think this is great question. Another question that come up from what I've seen in here is that are we in the fourth era yet? From what you present there.
I think we're on the cusp. Like the way that I always think of the beginning of the cloud computing era is when Salesforce.com launched in 2000, 2001. And Salesforce.com at that time had kind of not really a cloud computing model. They were like Netflix, using very classic, kind of infrastructure. But they were the first to really kind of do that on-demand billing, software as a service. They really coined the term software as a service. So I see that as that's my marker for the beginning of the cloud computing era. And I think the advent of OpenAI and ChatGPT this year, at the beginning of the year, that's really sort of our marker. So I think we've just really started to enter it. And so we're going to see a lot of change in the next 5 to 10 years. You can already see change. People are using a lot of the development Copilot tools to help them write code. And it's just going to keep accelerating.
So autopilot, Copilot, I think we're going to see a lot of that. So I think we are on the cutting edge of that. I think let's open up and then get ready for that. Back to Salesforce a little bit here. I think Salesforce is based in San Francisco.
Yeah.
And 100%. Also they use AWS, right?
So they acquired Heroku, which was a startup that was all on AWS, and I believe, to the best of my knowledge, they're still operating there. They started transitioning a lot of their infrastructure over to be a little bit more cloud native a long time ago, but there's still a mix, right? So if you've got something that works, just like Visa with their mainframes, you stick with it a lot of the time because there's not a reason to change. So it's not really always about taking everything you're doing today and trying to change it. It's a lot more about looking at what is new and how you can embrace the new and take new initiatives that you're working on and use those new capabilities to actually do something different.
Great. On your presentation, one thing that I like a lot is about the pet versus cattle.
Yeah.
I mean the
pets versus cattle.
An analogy you use in that one is really a great one. People would understand that why you want to have a cattle instead of just one pet. I think this is really a good example for that one.
Well, like I said in the webinar, it just was a way for me to have a 30-second discussion to make it really clear the difference between the old way and the new way.
You got any more questions coming in?
Looks like we have one more.
One more? Okay. All right. With the continuous evolution of technology, what role do you see emerging technology playing in the post-cloud computing era, and how should business prepare for these changes?
Yeah, it's a good question. It's really broad, though. I mean, we've seen these attempts to sort of come up with the next big thing a lot of time. Like, Mark Zuckerberg got up and he announced that there was going to be this metaverse, which of course didn't crystallize because it was just an idea, right? So what we can do, and what we've seen over the past, is that when technologies are not just talked about and hyped, but when you see them actually being used for real world use cases and solving real problems, that's an indication, that's smoke, and so you know that there's fire there. So that's why I'm really hyped on artificial intelligence. I was an artificial intelligence skeptic, at least for artificial general intelligence, but I'm a real believer in a lot of what the LLMs can do in generative AI, and you can see that they're solving real problems today. And I think when we just keep watching for where we're solving real problems. So will quantum be a part of it? I don't know, but when we see quantum starting to have like big major breakthroughs and solving real problems, then we'll know that it's here.
Okay, great. A lot of things happening, right now and maybe in the future. I think we have to be aware of that. And I think today we have learned a lot from Randy. Again, like I said, we are lucky to have Randy to work with us here at NIPA Cloud team and give us a lot of suggestion and consulting, ideas, to help us moving forward with the NIPA Cloud here as well. Okay, there's any more question? No more, right? Is there no more question? Maybe Randy, you want to wrap up a little bit of?
Sure. I'll take a swag at it. So, I mean, people saw the webinar. You saw sort of the message about, adapt or die. It's really important to pay attention to some of these businesses that have done successful adaptation. So I didn't really cover this in the webinar, but you see that transition from mainframe to enterprise computing, and IBM made that transition. They were a mainframe company, and they were able to transition over to a services and software company and really adapt. And Microsoft was dominant during the enterprise computing era.
Yes.
And they were a box shipping company, no hyperscaler DNA, no data centers, and they did a massive transition and transformation into a cloud company. And now they're one of the top 3 clouds, arguably number 2 with Azure. They built all the hyperscaler expertise, which they did not have as DNA inside the business. They really transformed. And I mean, I don't know about anybody else, but if you look at Microsoft's stock over the last 10 years, they've just been crushing it.
Now they transformed to using OpenAI and then
and now they're really at the head of the AI at the AI movement, right? So we can see that even the largest companies can successfully transform. It's not a question of money; it's a question of will and intent. So. It's really just up to you to sort of take this information and use it to better yourself at your business or to make your business more competitive.
Great point. I think we have to be have a strong intent to do things that is maybe out of the box.
Outside the box, yeah.
Outside the box. I think that's something that hopefully we can learn from Randy today. Okay, so for us, I think. NIPA Cloud is setting up this kind of webinar series, and we hope to continue doing this. This is maybe like at the beginning, even though it's the last month of the year, but I think next year we're going to plan to do more of this. Maybe we're going to have more guests, but again, we'll probably have Randy again next time to talk about something that you may not know before, but I think Randy will have something in his pocket to pull out and discuss with you all again next time. But for NIPA Cloud, I hope that you understand, you learn a little bit more. Please go to nipa.cloud to learn more about how you can be part of this, technology innovation in terms of migrating your existing legacy hardware onto the cloud, either public cloud or private cloud. I think we can help you on that one, and hopefully if you need any a kind of consultation of how to migrate to cloud, please let us know. And hopefully that today we can learn from what Randy talked about it. And if you have any question, you can write to us. We have all the channels to talk about here, as you see on the screen here, right? YouTube, Facebook, LinkedIn, all these channels. Okay, Randy, thanks a lot.
Awesome. Thank you.
Okay, all right. So see you guys. See you all next time.